Hello, we are still doing Mapwork, unit number 6, Mapwork. Last time we were doing lesson number 25 and we spoke about the floor plans. And today we are looking at the scales. This is on page 102 of your textbook. So they say being able to read and apply map scales is an important skill. It is equally important to be able to describe the position of a place like your home or school in relation to your surroundings. If your friend wants to visit you, you need to be able to give them instructions on how to find your home. For example, turn left at a traffic light, drive past the first street, etc. A map scale is a ratio of the distance on the map to the distance in reality. Please, let's get the definition right. It's important to know this definition. A map scale is a ratio of the distance on the map to the distance in reality. There's distance on the map and distance in reality. Okay, so a map scale is the ratio of the distance on the map to the distance in reality. Please know the definition. If a map scale is 1 is to 10,000, okay, it means the map scale is 10,000. You will always get the ratio in simplest form like this. If not, you know how to write the ratio in simplest form. We have done that in maths. Okay, so the distances on the map are 10 times smaller than what they are in real life. If you were asked the question, the distance on the map are 10 times smaller than what they are in real life. Okay, we can also say that real life is 10 times bigger than the map. So I don't want to read this, it might confuse you. There are two kinds of scales. The first one is a numerical scale and the second one is a graphic scale. So let's look at the first one, which is the numerical scale on page 103. Numerical scale sometimes is called the digital scale. A numerical scale is expressed in numbers as a ratio. For example, 1 is to 250,000 or 1 is to 14,000. You will always get it in simplest form. If not, you can make the ratio in simplest form, right? Simplest form means you will always have 1, okay? And this, now the map scale is 250,000. The map scale is 14,000. Okay, the right hand side of the column means the map scale. This is the column, this is the right hand side, it's the map scale. This is the column, this is the right hand side, it's the map scale. They say we can use this formula when we have to convert between map distance and real distance. And the formula to get real distance is map distance times map scale. And we know where to get the map scale. It's the right hand side of the column. Okay. So they say that if the map distance is measured 15 centimeter and the scale is 1 is to 500, what is the real distance in meters? Formula: real distance is map distance times map scale. We know our map scale is 500 and map distance they gave us here, it's 15 centimeter. Then the real distance would be 15 times 500 and that would give us 7,500 centimeter. Then we can convert centimeters to meters. You know how to convert. King Henry died miserable death called missile. You remember that? Okay. And now we have the second example here. They say find the real distance in kilometers between two towns. If you measure on the map as the crown flies, that the distance is 20 centimeter on the map, right? No. Find the real distance in kilometer between two towns if you measure on a map as the crow flies, that the distance is. So the map distance is this one and the map scale is that one. And we know our formula, real distance is equal to map distance times map scale. So we get 20 times 20,000 and we get 400,000 centimeters. We convert that to kilometers, okay, and we get 4 kilometers, okay. You know how to convert. And then find the map distance. Now they are asking for map distance. You see, they were asking us for real distance, and we've got the formula for real distance, that the real distance is equal to map distance times map scale. But we don't have the formula for a map distance. So now they say find the map distance if the real distance is 25 meter and the map scale is 100. Now, before you even look into the problem, I want you to take down this. This is the formula to find the map distance. Okay, so don't worry about this. Focus on the formula and you write the formula down. Map distance is equal to real distance divided by map scale. So we know our map scale is 100. Okay, so our map distance is going to be real distance, which is 25, divided by map scale, which is 100. So our map distance is going to be 0.25 meter. To avoid the decimals, we convert this to centimeters and we get 25 centimeters. That is the map distance. Okay, so please practice on that one. Just go back and practice the example. But the key thing that you need to do is to take these formulas. Real distance is equal to map distance times map scale. And map distance is equal to real distance times map scale. And the map scale, you always find it on the right hand side of the column of the ratio. And the real distance or map distance, they will give it to you on the question or statement. Now let's look at number 4. They give us the layout plan of a school is given with a numerical scale. Let's see if I can minimize that. So this is the scale 1:500. So our map scale is 500. Okay, so let's check now the question. Find the dimensions of the sport field, length and width, right? First measure the length and the width of the sport field with a ruler. Oh my goodness, I don't know if this will do justice, but because I'm zooming in and out, I don't think I can. But for you guys, you can. So we are looking at the sport field length and width. Okay, length would be the horizontal distance and the width, hey, I'm not sure now. Hey, okay, so okay, the length, let's take the length to be the longest side and the width to be the shortest side. Yes, let's do that. So you're gonna take your ruler, you're gonna measure the sport field, okay, and okay, obviously you need a printout for this question. Ruler, you measure your sport field, okay, and your distance is up to you. Your units, it's up to you that you use centimeters or millimeters. It's up to you. Then once you get the map distance, you can calculate the real distance for the length. And you do the same. You take the measurements on the width, okay? And once you have the map width, you can multiply it with the map scale and you can get your distance, okay? So they've already done it for us. The length is the longest side. They measure it to be 8 centimeters. The width is measured to be 4 centimeters. So real length, it's the map distance times the map scale. Okay, and they got 4,000 centimeters converted to be 40 meters. And the width is the map distance multiplied by the map scale gives us 2,000 centimeters, and that gives us 20 meters. So you see how we work around this. They say find the real length of the school hall. You do that, you look at the school hall, the longest side. Which one looks like the longest side? This side, I think, looks like the longest side. You measure it, okay? So you can get the real length. Okay, and now we look at the second type of scale, which is the graphic scale. Graphic scale. Now you know how to work with a numerical scale, and now we get a graphic scale. Okay, this is how they give us the graphic scale. They say a graphic scale uses a bar consisting of blocks to show distance. Each part or segment represents a particular distance. You see, so a black block represents 200 meters, and this white one represents 100 meter. From here to here, it is 200 blood. From here to here, it is 300 minus 200, which gives you 100. You see that? They say each part or segment represents a particular distance. Although these sections, they look equal, but they are not equal. You always get it by taking the last minus the first one. So here it's 200 minus 0. I get 200 meter. So black represents 200 meter. But for this white block, it's 300 meter minus 200 meter, and the answer that I get is 100 meter. So the white block represents 100 meter. That is the graphic scale. Okay. Now, they say, how do we use the graphic scale? Yeah, it's hot where I'm sitting. How do we use the graphic scale? You take your ruler and you measure the length of one segment on the graphic scale. Now measure the straight line distance between the 2 points on a map. Calculate how many segments are divided into the measured distance. Multiply the number of segments by the given scale to get the real distance. Okay, I think I said something incorrect here. Let us look at the graphic scale again. Okay, they say a graphic scale uses bar consisting of blocks to show the distance. Each part or segments represent a particular distance. Now they say, how do we use a graphic scale? You take a ruler and you measure the length of one segment on the graphic scale. So I will take a ruler and measure the length of one segment of a graphic scale. Now measure the straight line distance between 2 points on a map. So I will measure on the map and then calculate how many segments are divided into the measured distance and multiply the number of segments by the given scale to get the real distance. Let's do this slowly through an example. They say, for example, if 1 centimeter on the graphic scale is 10 meter, okay, 1 centimeter on the graphic scale is 10 meter in real life. The measured distance on the map is going to be is 3 centimeter. So I am going to say that 3 centimeter, this is the measured distance on the map distance, divide by 1 centimeter, which is the length of one segment. Then I get 3 segments. Then the real distance is 3 times 10, okay, which is the scale, okay, which is the map scale. 3 times 10, then it gives me 30 meter. Let's go through an example. If you don't understand this, don't worry, we will redo it again slowly. They say I must study the floor plan and answer the questions. Okay, this is the floor plan in page 106. There's a sofa, window, door, bookshelf, and window, and we are given the graphic scale there. Okay, so they say that I must use the graphic scale to determine the real length. Okay, remember I'm looking for real length. Okay, so now of the bookshelf. Okay, so now the length of the scale, uh, the length of the scale is 15 millimeter, is equal to 40 centimeter. Okay, so now I must convert my units to be the same on the ratio, remember. So I'm going to convert 15 millimeter to centimeters as well. So I get 1.5 centimeter. So I have 1.5 centimeter is to 40 centimeter. Okay, so my map scale is this one. Okay, so I have 1.5 here. So I am going to use this 1.5. So now I measure the length of the bookshelf, right? And the length comes to be 45 millimeters, and I convert that to centimeters. Okay, so this is the map distance. Now I want to get the what do you call it, the real distance. So the real distance is going to be the map distance multiplied by the map scale. Okay, map distance multiplied by the map scale, and I divide by this scale. If it is not 1, I will divide by that, and I will get the what do you call it, the this is the map distance multiplied by the map scale. So I will get the real distance. Okay, the real distance. Okay, and I convert that real distance into meters. I divide this by 100. You know, King Henry died miserable death called missile. So now let's continue. They say find the real length of the smaller sofa. So I will still use this. They gave me the length of the scale, okay, which is 1.5 centimeter to 40 centimeter. The important thing, I'm gonna go and take the length of the small sofa, okay, which will be my map distance. Okay, scale, it's still the same. You see it? Okay, and now I find the length of the smaller sofa. Okay, so this will be my map distance. So my map distance multiplied by my map scale, I'm going to get my real distance, okay, which will be 120 centimeters. Okay, let's scroll and see 120 centimeters, but I must divide by this number if it is not 1. So I divide by 1.5, then I get 80 centimeter. You see that? In 80 centimeter, I can convert it into I can convert it into meters. Okay, so from centimeter to meters, I will get 0.8 meters. Okay, so I just need to rewrite this in a way that you will understand it. Okay, so this is a little bit complex to understand, but I want to show you in a simplified way. Okay, so with a graphic scale, this is what you will be given. Okay, so let's go through this. So with a graphic scale, right, you will be given one, a block, okay, and then number 2, you'll be given a length of the scale. For example, that length of the scale, they will give it in the form of, for example, 1.5 centimeter is equal to 40 centimeter. Just always make sure that the units are the same. So if the units are not the same, just convert one side, right, of the units. It can be any side, okay? And then after doing that, if you want to, you can rewrite this length of the scale as the ratio like this. 1.5 is to 40. Okay, so once the units are the same, you can rewrite it as the ratio. But what we note here is that the ratio is not in simplified format like we did with the numeric scale. Okay, so here the what do you call this, the ratio is, or the scale is not in simplified form. You don't have to simplify it. Okay, you don't have to simplify it, but just take note of this. Let me just do that. Oh no, I don't want to do that. I don't want to do that. So what I want to do, I want to make you know that the left hand side is to right. Okay, so in this case, the left is the real scale. Okay, and the right would be your map scale. So once you know what is on the right, left, it is the real scale. What is on the right, it is the map scale. So in this case, this is the formula that we use. This is the formula that we use. This is the formula that we use to calculate the real distance. It's similar to the numerical scale. Okay, so please take note of this formula. In this case, remember, with the numerical formula, with the numerical scale, real distance was equal to map distance times map scale. That was it, because the ratio was in simplified form. But with the graphic scale, real distance is equals to the map distance times the map scale divided by the real scale. Always, please take note. This is applicable in the graphic scale. What have I done now? This is applicable for graphic scale. Don't worry, I will fix this. I will fix this. Okay, so the real distance for the real distance for graphic scale, this is how we calculate it, and this is the formula. So please write this formula. And the map distance, you will measure it. Okay, so let me write here that the map distance, you always measure it on the map. Okay, map distance is measured on the map. Okay, so the important thing is to get your length scale. Okay, and you write it in a ratio format, so you know the real scale and the map scale. And then after that, you get your map distance. How do you get your map distance? By measuring whatever distance that they want in the plan that they gave you, or in the map that they gave you. And once you have done that, you will be able to calculate the real distance. So let's go back to the example and look at it again. So they say example 1, they gave us this map. Let me minimize it, so I hope this time you will follow. Please, if you don't follow, we will practice this until you get this right. So now we've got this map. Okay, so they say use the graphic scale to determine the real length of the bookshelf. You see, the real length, they mean the real distance. Okay, real distance, don't get confused. So the length of the scale, this will be given to us. However, the units are not the same. Okay, the units are not the same, so I will convert one off. So I decide to convert this side. Okay, then I get 1.5 centimeters. So now the units are the same. I can write this in ratio format, and I will have 1.5 is to 40, right? And the left hand side, it's the real scale for me, and the right hand side would be the real scale, map scale for me. So this would be the map scale, this would be the real scale. Okay, now I know that the formula to calculate my real distance or my real length is, the formula real length is equals to map distance times map scale divided by the real scale. So I go back to my problem. So I measure in my map. So here they've measured the length of the bookshelf and they found it to be 45 millimeter. But because we are working in centimeter, they converted this in centimeters. Okay, so I have the map distance. Now with the map distance, I come to my formula. So here, the only thing that they did not write, instead they wrote operation. They were supposed to write that real distance is equal to map distance times map scale divided by real scale. Okay, so if we look at our map distance is 4.5 centimeters, our map scale is 40 centimeter, divide by our real scale. Then we get the real length of the bookshelf. And if you are asked to, you can convert that into meters. Then they converted that into meters, and this is the real length of the bookshelf. Let's look at the next example. So they say find the real length of the smaller sofa. Okay, so they gave us the scale. Okay, it's 1.5 is to 40. We know this is the real scale, this is the map scale. Okay, and they say the length of the smaller sofa is 3 centimeter. This is being measured. So now the real length of the sofa, or the real distance, is equal to the map distance, which I measured, times the map scale, right? Divide by the real scale, and they get 80 centimeter. Okay, it's one and the same thing. Okay, so I hope now you get better understanding. Okay, so I just want to, now we go to the next page, and we have advantages and disadvantages of the scales. We have a numerical scale, we have a graphical scale. The numerical scale, the advantage is that you only need to calculate one distance, therefore it is easier to do the calculation. If the size, the disadvantage, if the size of the floor plan or the map changes, the scale is no longer accurate. For me, I would say it's easy because the ratio is simplified. And then the advantage of the graphic scale, if the size of the floor plan or map changes, the map will change proportionally and the scale will remain the same. You will have to measure very accurately and do more calculation to find distance. Okay, just know the new formula. That's it. Okay, so now let's look at the, now we have the activity 27 that you will need to practice doing it and see if you are getting the grip of this. Okay, please, let's do activity 27 and we will do the corrections together just to make sure that we understand what needs to be done. Okay, don't remember to write your formula for the graphic scale. Okay, so this is your graphic scale. Please take note, you will always get this. Okay, so what you have to do for yourself, just ensure the units are the same, rewrite that in terms of ratio, and you know what is the real scale and you know what is the map scale, and you write your formula for graphic scale, that real distance is equal to map distance times map scale divided by real scale. If you know that, you should be able to win with doing the problems for the map work. Okay, so let us see if this brings us to the end of map work. So you see, you are given, this is the numerical scale for the first problem. The second problem, you are given the graphic scale. Okay, so please go for it. And this brings us to the end of unit number 6, which is map work. All the best as you practice your exercises.